चलिए दोस्तों शुरू करते हैं without wasting a time. In this video, we are going to talk about the ASIC, application specific integrated circuit, and it's like in a chip. Okay, it's provide high speed with number of ports. And there's the one terminology is FPGA. It's in a field programmable gate array, and this is similar to ASIC, but we can reprogram. So basically, the difference between the ASIC and FPGA is ASIC you cannot program, and but the FPGA you can program. So ASIC is built for the specific application like for the VXLAN or different kind of feature, and we cannot change it. Once it's done, once the what are the features that available in the ASIC, that we have to live with that. But FPG we can reprogram. So this is the basically one of the picture I find from the Google with respect to pipeline the ASIC. So on the high level, you can say these are the things. When the packet reaches the interface, L2 lookup will happen, L3 lookup will happen, then ACL will progress. So this is the pipeline. This is ASIC does, okay. And simply sometimes we see that tag say this is not supported. What do you mean by that? This ASIC is not supporting, or your packet need first ACL lookup, then L3 lookup, then L2 lookup, but the pipeline saying the this ASIC will do first L2, then L3, then ACL. So that kind of sometimes limitation hard on the ASIC. And then we have one more term is buffer. So buffer is simply named that device block the memory to handle data during the net routing process, or you can say when you're sending a data from the high throughput link to low throughput link, or high bandwidth link to low bandwidth link. On that time temporarily you need to store the data. On that time buffer play a role. And then the one more terminology in headline of blocking, when here in the when multiple packets from the same output add another packet that need to be sent to different output. There you can see that we have a two red packet that want to be sent on this outgoing interface, but behind that we have another this green and yellow packet are waiting. This kind of blocking is headline blocking. Headline blocking can be avoided by place of the shared buffer, or we can do the output. We can place some buffer at the output port. Here we can put the buffer so can packet come and wait for here. Or in the bigger chassis kind of architect, you will see the virtual output queue. So virtual output queue is basically on the in the chassis kind of architect, you will see that multiple line card will there, fabric card will be there. So on the every line card we have an ASIC, and the fabric card also we have a fabric ASIC. Okay. So when the packet will reach on the ingress line card, so on the ingress line card also you will see the one more buffer is the virtual output queue. So that buffer will be the on the per port basis. Okay. So simply what we'll do, packet will be in the virtual output queue, and until unless fabric don't give the go ahead to send over the fabric to ingress line card, this packet will be live in the virtual output queue. So what problem will be solved? So in case of any congestion, so ingress line card only will face the congestion. So overall whole chassis will not face the congestion or other issues. And one more term is deep buffer. So you can say deep buffer is it will hold the more data, but it will increase the latency. So we can see that more hold. So once it hold the more data, so more latency will be there. So once we have to decide on the buffer, we need to think about the how our application want it. Okay, what is our requirement? So it's important to understand how the traffic flow will happen while we design the deep buffer. Okay, and deep buffer majorly come into the picture in the long transmission link. Okay, where the retransmission packet can be the critical. So this is the picture I took from the Cisco xrdog.io site. So this is how virtual output queue work. In this picture, you can see that we have on the ingress interface. This is the NP network processor. On this network processor, we have this 8 port, and we have an 8 virtual output queue. Okay, and this virtual output on the ingress line card will only be able to send the packet once we'll get the credit or go ahead from this egress VOQ scheduler. Once you get the credit, then only it will send the packet, and the packet will process on the egress interface. We can say once the lookup is done and the destination is identified, so this ingress VOQ scheduler and egress VOQ scheduler can work together. So this can ask, can I send the packet once it will provide the go ahead, so the forwarding will happen.